Hey, this is an example of solving system of equations with three variables. Let's have the example. Your problem is find the values of x, y, and z in the system. X plus y minus 3z is equal to 6. X minus y plus 2z is equal to 5. And x plus y plus z is equal to 6. Usually, systems of equations with three variables is in three equations. What is the first strategy? First, you need to determine which variable are you trying to eliminate at the first round. And how do you eliminate? So, you could eliminate a variable by pairing them up and by elimination method, meaning to say you will apply addition or subtraction. If nothing is eliminated by adding or subtracting, you may probably need to multiply an integer to match a coefficient to the other variable, to the other equation. So looking at your example, I think I prefer to eliminate y, because when I add the first pair, y will be eliminated, the first and second equation, and then my second pair is second and third. When I add them, y is also eliminated. So on my first round, I am able to eliminate y by pairing. Let me show you the actual work. If we pair it up and perform addition, x plus x is 2x, negative 3 plus 2 is negative 1, negative 6 plus 5 is negative 1. And that is your first new equation. Second pair will be the second and the third original equation. So I will add them as well because y will be eliminated by addition, elimination method. So x plus x is 2x, 2 plus 1 is 3z, 5 plus 6 is 11. And now it looks very familiar. This is what we've been doing, the systems of equation into unknowns. The same, very much the same rules. So meaning to say, the systems of three unknowns is just a higher difficulty of case because of the original three given equations with three variables. Now it's reduced to two new equations after eliminating y. The same strategy follows. Your next goal is to be able to eliminate the next variable. Looking at your example, I think it would be easier to eliminate x by subtraction. I'm going to do it backwards. 2x minus 2x is 0. 3 minus negative 1, it becomes a double minus, meaning plus. So 3 plus 1 is 4. 11 minus negative 1 is going to become plus 1. So 11 plus 1 is 12. X is eliminated. 3 plus 1 is 4. 11 plus 1 is 12. And now it's very clear. We will find your first variable, value of z. Dividing both sides by 4, your z is found. It's equal to 3. What do you do next? You work backwards. From here, you're going to choose between the two equations to plug in, substitute your z, and you will find x. I chose the second one because it's all positive, less negatives, less mistake. I will now substitute z is 3, and here it is. And we will find x at the end of this part. 3 times 3 is 9, minus 9 on both sides, you have positive 2, divide both sides by 2, and you found your second variable. X is found is equal to 1. We are almost done. We already found x and z. We are left to find y. After finding the first two variables, you now work backwards and back to the original. You are now ready to find your last variable by substituting your last solved value variable, which is x. And of course, you can also use your first, you should also use your first found variable, which is z, and substitute them. And you are left with one variable unknown, which means we are now able to find the value of y because we already know what's x and z. We will just simplify. 1 plus 3 is 4. The minus 4 on both sides, and you found your last variable. Y is actually 2. And now you can write your solution. The values of x, y, z are: x is 1, y is 2, and z is 3. You would also encounter a different way of presenting the answer. It's actually called ordered triple. Ordered triple has a strict order, like the ordered pair. In ordered pair, x comes first, followed by y. In ordered triple, it should be x value first, and then y, and then z. When you write a solution, writing the value of each variables, rearranging them is not a problem. As long as x is supposed to be 1, you could write z first. Z is equal to 3, and then y is equal to 2. It does not matter. But in ordered triple, the order is very strict. X first, which is 1, y is 2, and z is 3. I would leave the checking part for you to verify if indeed the solution is actually correct. Let's review from the top. So again, the first strategy is to determine which variable you are going to eliminate by addition or subtraction. If nothing will be eliminated, it means you are supposed to multiply so that the coefficients match. You can rearrange them so that you can follow this pattern. So what we did is we eliminated y by adding. So after eliminating them, you have now a new system with 2 unknowns instead of originally 3 unknowns. Then you can now eliminate your first variable, your next variable, and you will finally find your first variable. After that, you substitute your first variable from the 2 new equations and find your second variable. By substitution, you find your second. After finding your second variable, you now go back further to your original and substitute your first found variable and your second found variable to find your last and third variable. After that, you can now write your solution, and you could also write it in ordered triple form. And that's it. Thank you.